Mason Proffitt. I'm a PhD student at the University of Washington in Seattle, although I'm physically based at CERN near Geneva. And I'm supported by IRIS-HEP. And in addition to my software work in the analysis systems group of IRIS-HEP, I also work on the Atlas and Methuselah experiments. So this is a list of the projects within IRIS-HEP that I've contributed to significantly. So the first is training. I've taught and mentored at several software training events organized by IRIS-HEP and the HEP Software Foundation. I created a PyHF-based implementation of the likelihood-based ABCD method, which is a background estimation method for analyses searching for new physics processes. So this is a generic implementation that can be used for any experiment. And I have helped organize the ADL benchmarks index. So this is analysis description language functionality benchmarks, which provide a comparison of standard functionalities of various analysis description languages, or ADLs. And then the last three projects on this list will be the main focus of the following slides. So there's FuncADL, or the Functional Analysis Description Language, CASTLE, or the Query Abstract Syntax Tree and Language Expressions, and ServiceX. So like I said, I'll go into more detail on these. So FuncADL consists of both a front-end interface and a back-end. So first I'll talk about the front end. So the interface for FuncADL is a query language for retrieving and transforming data. And it uses Python as a host language, but the query operators are based on LINQ, which comes from the C# language. So these transformations can include filtering and arbitrary Python operators. And so here is an example query, and I'll go through the steps here briefly. So first, there's an event dataset object, which looks like a table with a row for each event. And so in this case, just for simplicity, there are just two columns, two fields within each event number and electron PT, transverse momentum of electrons. And so there's one event number per event, but there are multiple electron PT values per event. So there's an array for each event. And so the first step in the query uses the select operator to project out just the electron PT column. So it just pulls out this column. Then there's a filter on these PT values, requiring that they be greater than 20. So any values that don't pass this requirement are removed. And then the last step, there's another filter, but at the event level, that also uses the count operator, so requiring that there be at least one electron value within the events that pass this filter. So then we just get left with these two events here. So the back end of FuncADL converts a query like the one we just saw into executable code that will perform the transformation specified by the query. And multiple backends exist so that queries can be run on different underlying file formats using different underlying software packages. So I wrote and maintained the FuncADL uproot backend, which runs queries using the Python packages uproot and awkward array. So these packages are used such that they can read any root files that don't require experiment-specific software to interpret, and they can be used for very fast file reading and array operations on arrays like we saw on the very simple example on the last slide. So basically a query goes into the backend and it produces executable code that can run the transformation. And FuncADL is an important component of ServiceX, which is a highly scalable data delivery service that's also a project within IRIS-HEP. It's designed to run on a cluster, but it can be run on any PC. And I also created Castle, which is another component of ServiceX, this is a language that specifies funcadl-like queries independent of any host language. So it doesn't depend on Python at all. And this language is used to send query requests to a ServiceX instance. So it looks like this, where a user writes a funcadl query in the funcadl front end, which converts this to Castle, sends it to ServiceX, which takes in the large data set that's queried against, and then it has funcadl backend instances that generate the executable code, run the transformation, and then ServiceX returns the query result, the actual data that was queried for, back to the user.